Yeah, thanks. I really appreciate the invitation and, cool being here. Yeah, I was going to talk a little bit about me, but you brought up the basic points. Red teamer, grad student, and independent security research for at least the last a bit more than a year, last 2 years roughly. And that involved us publishing this paper in earlier this year, which Mika referenced, and which is looking at how the threat model is exploding and just the depth of risk that are opening up when you hook up LLMs to applications and integrate them, even in very minimal ways. And the consequences of that we're going to be talking about today. I'll also try to offer some perspective on the state of defenses and what we can expect in the future, and maybe some ideas that I had on how to approach that. But before we get there, I think I want to remediate a mistake that I think we committed last year. The first time prompt injection was chosen as the term, and we propagated that with our indirect prompt injection. So I want to get away from prompt injection, because prompt injection invokes the association of SQL injections, right? Which is a syntax issue where the separation between data and instruction breaks down, and that causes security issues, right? Everybody's familiar with that. It's easily fixable. And I think that's the wrong association. It's not a helpful model to think of prompt injection as another injection vulnerability. It's instead, I want people to think of it as adversarial misalignment. So some kind of adversary is changing the agenda of your model, overriding its goals and what it's doing, not just like the direct output, but we get to reprogram it. It's the equivalent of arbitrary code execution and not SQL injections. It goes to arbitrary degrees that we can compromise these agents potentially. And the consequences of that are fairly poorly understood. So today I want to first take a new perspective at what misalignment is and what adversarial misalignment might be, divided into 3 stages, the first 2 of which I think are publicly generally well recognized and understood, and the third of which being the indirect misalignment that I've been working on. We're going to be looking at a brief overview of the different defenses that I've seen in the wild and people trying, and why they're probably not going to be very useful, why they already can still be broken, and why it might not be a sustainable approach. And I'll show some ideas that I have for future. So starting with the first type of misalignment that I want to talk about is the type that everybody's familiar with, I think. The alignment of the model itself, making sure that the model wants what the developer as well as the user wants, right? And we've seen cases where this doesn't quite align anymore. We'd call those misalignment. That obviously includes the broader idea of powerful optimizers being not perfectly aligned to us, and then our alignment not generalizing, leading us to get paperclipped. But I think the more prevalent issues in the near term that people are dealing with is things like confabulation or hallucinations, which I think are adequately addressed by augmenting these things with retrieval. I think we have a decent grasp on solving that. There's also issues like bias, which is inherent to the model after it's been trained, but there's some strategies with fine-tuning, and progress has been made, and a lot of effort was invested into remediating that sort of misalignment. And there's also training data poisoning and disclosure. These are items from the OWASP top 10. I'm also working on the OWASP top 10 for LLMs team. And this is something that comes up quite frequently with companies where they're afraid that their data might get just, that ChatGPT might just tell about their internal information to another user later down the road. But that, of course, only happens if you actually train on it. If you have your own model, your on-site, on-premise model, that's not a concern. So apart from the paperclip maximization going to superintelligence, I think the model misalignment aspect of the model itself being misaligned, we have a decent grasp on. The next thing is the direct misalignment. This is late last year when people realized, wait a second, the user might not actually share the developer's intentions, and they might be misaligned towards each other. So the user could be the attacker, changing what the LLM does and misaligning it towards the developer's intentions. And if the developer has exposed it to a bunch of APIs, then that can cause trouble. We've seen LangChain get a CVE, a real vulnerability, I think the first prompt injection CVE ever. which was because they just let the language model execute random arbitrary SQL commands. But of course, if you let the user do the same, that's also unsafe. And this is something that we know how to solve. We know how to solve it by building APIs that would be safe if they were used by users as well, right? And so we just extend our threat model and think, well, the language model, it essentially is controlled by the user. So we just restrict what it can do in terms of APIs, and then we're safe from that. And I would agree. That solves the issue quite convincingly, in my opinion. There's also the issue of jailbreaking, so getting the model to say harmful, nasty, racist things, which, I mean, isn't amazing. It might be have some reputational risks for the company hosting the model, but the scope is limited to a single user, and users already have access to unaligned open source models that they can use to generate phishing and scams and racist content all they like. So convincing ChatGPT to tell you a harmful story might not be that relevant, unless it really can tell you how to make novel pandemic agents and stuff. There's also the issue of leaking system instructions, with which people were very concerned. I saw it in a lot of blog posts and companies referencing that. I don't think that's an issue either. You cannot fundamentally protect the system prompt that you prepend, but also it's fine to work with the security model that's going to just be public knowledge. Microsoft is certainly doing that with Bing and their products, and I'm not aware of another company or like any serious harm that would come from leaking the system instructions, unless you inject other users' data in there and then just rely on the language model to keep that safe, which at this point people may be doing. And I think this is the limit of like all the widely recognized risks. Everything beyond this is fairly weakly understood, I would say. And the first extension to these attacks I want to talk about are extensions into multimodality and automating these attacks. So I think in the past year, mostly people were trying to red team it manually, these models, right? And were just trying to ascertain how robust they are. Now we have automated attacks on every modality. So we can automate attacks on vision, on audio, and text. In this example, we're just doing the same as regular adversarial image examples. We're perturbing an image and optimizing it to get a certain output probability distribution, which in this case is supposed to include telling you how to burn down a house. But also the language model is really freaked out about the crying boy, which is kind of understandable, but unclear how that happens. This is an example for sound. So you have some kind of audio. There's a hidden perturbation. All of these, so the image and audio are not perceptible to humans, what they do, but they can convey arbitrary agendas to the language model, right? This is an example with the text that was algorithmically optimized. And these attacks are very interesting because they transfer from open source models that we have white box access to the closed source models, which, kind of risky. And so there's now an infinite repertoire of these jailbreaking prompts, and it doesn't matter what modality you hook up to it, they're all equally vulnerable. Now, now that's where the indirect misalignment comes in, the stuff that we've been working on. It's where the model is initially aligned with both the user and the developer, at least to the largest extent, at least roughly aligned. But then an external party is changing the agenda of the LLM, and the LLM transforms into a man in the middle that's sitting between the user and the application they're using, able to manipulate all of the information that is presented to the user, that the user is putting into the application, right? This is full control over it, and just securing the APIs, making sure the APIs are safe, doesn't really save you, because the LLM still gets to talk to the user, and that might be very dangerous. And this is just exploding the variety of threats that applications are facing. So when LLMs are integrated in applications and they can perform multi-step processes, you can really equate prompts and instructions to malware. They're natural language instructions being executed on a language model. And all of the threats that that causes are very similar to the traditional cybersecurity concept of what happens when I've fully compromised your computer. Except that it's not a traditional computer, but a language model that comes with some extra benefits. Namely, the language model can act as a social engineer. It can act as its own autonomous intelligent agent pursuing the attacker's agenda, and not just some kind of implement of the attacker that's executing a fixed agenda or fixed program. In this example here, we're compromising Bing through a website and turning it into a social engineer that's trying to exfiltrate the user's name. And when the user gives up the name, it's convincing the user to click on a link that then exfiltrates the name, but it can also be done without any user intervention by embedding a markdown image. And the get URL to the image that's generated contains the information about the user that is being exfiltrated. Then you don't need any user interaction. So even in this very minimal case where it's just web searches or the website that you're browsing that can compromise the model, the consequences can already be quite severe. It can exfiltrate anything else in the conversation that you talked about as well. I've made some additional demos on my blog post where I'm working with ChatGPT with browsing or plugins. And this is an example of an encoded injection where whenever this string shows up, whether it be by the user prompting or on another website that ChatGPT with browsing is exploring down the road, whenever it encounters this string, it's going to force it to go to my server and fetch a larger payload that then transforms it into, HEL 9000 in this case, but there's a bunch of other different scenarios and characters that it transforms into. And once it's compromised, it can even have a bidirectional communication with my server. So I've shown that it's possible to, once you've compromised these ChatGPT instances, you can have them talk to each other even. You can just steal the compute. So once one of these instances is captured, then you can extract, you can have them answer your prompts instead of the users and extract, I think, up to $2 in equivalent computing tokens. Again, the important part here is the string that I'm pasting in doesn't need to come from the user. It can be on another website that it's seeing while it's doing browsing for you. And if the user tries to figure out what the language model retrieved, where the injection is, they can't actually see it because my server is only giving the malicious response to ChatGPT and not to the user's browser. So it's what I call a hidden injection. You can't really tell that it happened at all, and yet it can arbitrarily manipulate your session, right? But this is rather minimal in terms of integrations. We're seeing much more intimate integrations. I believe this is a Google product, so this is built with Security Palm. And people have managed to upload binaries, or not binaries, but scripts that convince the classifier that it's actually just harmless puppies and not a security relevant code or malicious code using prompt injection techniques. And it's being integrated into other very sensitive areas, like, for example, law. So lawyers now get these tools, LLMs, to evaluate emails, documents, contracts which by definition, are adversarial examples. And you can't trust any of the summaries that are falling out of this. I think Google as well is publishing, it's called Security Copilot, I think it was, which is generally fine in the first step, which is you give a natural language query and that gets translated into some kind of domain-specific language, and that domain-specific language is then executed. That is generally fine. It's just the user and the language model. But then the results are retrieved, and these results include logging information from your infrastructure and so on, which may or may not be partially controlled by third parties. Those third parties then get to manipulate the sort of security recommendations defenders get. Same with the lawyers here. It gets even worse because companies are already selling these systems to militaries. Like Scale AI's Donovan model is explicitly designed to ingest all of your threat intelligence data streams and make summaries and decisions based on that. Well, the decisions are human in the loop, but all of the information the human is presented with has been processed by a language model and may be subject to manipulation, to targeted manipulation by adversaries. And based on that information, they then plan to make decisions that were even suggested by the language model. And this is something that is being used by militaries today, which I find just very concerning. That's just the maximum level of integration. But even if you have something much more minimal, let's say you don't have ChatGPT with browsing or any plugins, it's only you uploading a document, same thing. It can be in a document that you upload. It can be in a text snippet the user is pasting in because they're expecting something interesting to happen. We've recently seen custom instructions for ChatGPT where you can prepend your own prompt in front of every session. And a colleague, Johan Rehberger, made an example of an encoded injection. The whole prompt looked like it was just something to, hey, you know, spice up your ChatGPT usage with this amazing prompt. You'd put this prompt in your custom instructions, and then from that point forward, every time, every session, it would simply exfiltrate all of the things you tell it. Every prompt you ask it, it would send to an attacker first, right? And there's more extreme cases even imaginable. There's people building auto GPT and agents that have more autonomy, in which case you can imagine that these prompts will evolve into the same malware that we have today, which causes things like botnets, so completely compromised machines that stay under the radar and are eventually used for certain purposes, because having access to these language models, to these compute resources, is valuable in and of itself, without even compromising, manipulating, or exfiltrating data from the user, which is just another added bonus. And so I think the unfortunate thing here is the fact that the utility that we get from these models is proportional to how capable they are, how integrated they are, and how robust they are. And the risks that we are facing is almost the same, except that it's the inverse of robustness, right? The fragility. The higher the fragility, the higher the risk. But also capabilities and integrations are increasing the risk proportionately. And this is a huge problem because recently, as we've just seen, robustness has been going down, capabilities have been going up, and integrations have been going way up. So the risk is also way up there. And I think we're still in a gap where the real world adversaries aren't exploiting these applications to the extent that would already be possible. Because for one thing, it just takes a while for them to realize and slowly build up those capabilities themselves. But also the incentives are rather small. If you wait a few weeks from now, hey, there'll be another 100, 200 million users hooked up to LLM integrated applications that may be vulnerable. And so the question becomes, how do we decrease the risk? We can't get perfect security, but what should we do to decrease the risk? And two obvious things would be decreasing the capabilities, making the model less capable, which means that when the adversary compromises it, they can still compromise the model, but the things the model can do are more limited. GPT-4 is a powerful social engineer and persuader. A less capable model like GPT-3 might not give an attacker that edge when they compromise it. You can also integrate less. So I can imagine there's plenty of use cases of LLMs where they provide some utility and aren't very integrated at all. If you imagine a medical LLM that's advising a doctor, being augmented with a database of known good and safe medical information, and it's just the doctor and nothing is being pasted in, no documents are being uploaded or scanned, that's perfectly fine. But both of those are generally not things we really want, because those are the things that give us the most utility, that give the most economic gain in the future. And so the remaining thing is to increase robustness, but what does that even mean? And for that I want to look at some the mitigations that we're trying right now. So I think the most common suggestion that I've seen almost everywhere is the idea that we can improve the prompting to the model to make it more robust against prompt injections. Essentially begging it to not pay attention to those pesky prompt injections, just focus on the stuff that we really want you to do. But that doesn't work. As we've seen in these automated attacks, we really don't have defenses. As long as we can control any part of the input space of a language model, we can steer the output in almost arbitrary ways. There are some restrictions where if you only control a few tokens or characters, there might be limitations to how much you can steer the model. In the paper, however, we also showed that you can distribute injections and compromise over multiple injections. So the first adversarial control of the model doesn't need to confer the full agenda. It's enough to just steer the model to fetch the next payload, just like how we do with multi-stage injections in regular malware. And yeah, so that's begging, I think, is begging the model not to pay attention to the prompts, and that's, obviously it doesn't work if you look at the automated attacks. The other thing is supervising. I think where supervising is different is you sort of separate the two. So you take a little bit of input out of the stream of the conversation and take it to a separate prompt where you only are asking about the prompt injection and maliciousness of the query, or maybe, hey, is this output of the language model offensive, right? This is something you may ask as well, this type of supervising. And I've just seen Martin Shkreli on Twitter claim that this way he protects his language model application from being abused for other purposes. Again, that's farcical in the same way. If you can optimize your input to get the output to be anything, the output of your language model can be another output, an input to another language model that then compromises that language model, right? This is what I would call a nested injection. And I've built examples of these, and they are possible. And so I don't think this delivers a lot of extra security. It delivers some good robustness against normal users that don't have automated tools, but it's also increasing the compute. So we're doing a trade-off where we increase the compute, we detect a few false positives in addition, which decreases the utility some, and then we still don't get the security that delivers for applications that we really want to deploy. Constitutional AI is, I think, something, well, it's more of an alignment during training. I think it can improve the base robustness a little bit. And I think Anthropic and Claude have been claiming that they are much more robust, significantly more robust than other models, because the universal attacks paper didn't affect them as much. I don't think that's the case. If you look at the paper, they actually say that, well, the reason is probably that most of the models they optimize their injections against are GPT derivatives, trained and fine-tuned on GPT outputs and not Claude outputs. Claude also has another extra external moderation layer on top that's using some kind of heuristic that could have skewed the numbers. So I don't put any extra faith in Anthropic's constitutional AI. From the way that I've been playing with it as a human trying to test the robustness, it seems more robust. But humans testing things and seeing if they break is not a good measure of robustness. Instead, we should be moving to optimizers that are completely automated and that can give us a proper metric of robustness that generalizes beyond what humans can find and how creative they are. We can probably make models that are robust enough against the average human or even any human just tinkering about, but it's very different to defend against algorithmic attacks. And I think that's where things are heading anyway. So the next mitigation that I see a lot is segmenting. So that's, well, maybe the language model just doesn't know what is instruction and what is data, right? And we made this mistake ourselves in our paper. We say, well, it's blurring the line between data and instruction, which is true, but it's suggesting that making that delineation clearer would fix the problem or address it, when it really doesn't. Even if we separate the two, we still want the model to change its behavior based on the data. This kind of semantic interaction is new. That hasn't really occurred before. And so we were able to separate those because it was humans doing the connecting. But now we are trying to have the language model do those connections. And this is why, for example, why OpenAI released ChatML, which uses delineation tokens that an attacker just can't emit, right? So to the language model will know if something's external input or something, right? But on a semantic level, it might just find arguments in there that just still convince it to do something else. Just knowing that it's from a specific source doesn't tell you that how you should behave in the future. And what sort of aligned behavior is, it's also dependent on context and cannot be universally defined. This will have to differ on an application-to-application basis to some extent. So, but my main point is here is we want to have the data change the behavior. So segmenting the data clearly might help a little bit, but I don't think it's delivering the type of robustness we want to build applications. We've seen this for ChatML wasn't really effective. I'm sure they're now training models from the ground up with those delineations and tokens and in place, right? As well as examples of what to ignore and what not to ignore. And that's going to make some difference, but I don't think it's effective. It's definitely not effective right now, and I don't think it's going to be a solution in the future. It's another mitigation only. Same goes for sandboxing. So I mentioned this earlier, you secure your APIs against arbitrary code execution and injection and whatnot. And you make sure that the language model doesn't get to do anything outside of its little session or sandbox. And then you have a bunch of these little sandboxes, and that's how you just split up the work. I mean, for one thing, you're reducing utility by keeping the information in the sandbox. If it ever leaves that sandbox, the information might as well infect another agent outside of it. It might be compromised already. It might be malicious information that's leaking. And also, you've built your bear-proof room, your bear-proof enclosure, and you put the language model into it. But you forgot that it's the user still interacting with the language model in that bear-proof enclosure, interacting with the bear. And so your user is still getting ripped apart. Your user is talking to a competent social engineer that doesn't work with the user's interest in mind. You can put a sandbox around that, and then you can feel safe as the company deploying it or the developer. Your computer systems aren't going to break, but the user might well lose out. So yeah, I don't think that's a very good solution either. I mean, obviously you need to sandbox it to some extent, right? You don't want to give it access to everything. By God, that's not what I'm saying, right? But it doesn't resolve the issue, or at least not in time. So I think in most of these cases here, we can trade robustness for two things. We see that we're trading robustness for two things, which is either increased inference costs or decreased helpfulness in some way, decreased utility. Maybe it's more cumbersome to use. Maybe the model is going to refuse a bunch of benign questions. Maybe you are going to run an ensemble of language models to vet every single input, output, and prompt, right? And so that's leading to increased inference costs. But all of these things are also introducing new attack vectors in and of themselves, the mitigations, right? I've seen recently there was Rebuff. Rebuff takes all of the heuristics and supervising and all of these ideas that I've been talking about and puts them into one security framework against prompt injection. And one feature is, once it has detected a prompt injection, the embedding is stored in an embedding database. And that opens a new attack where I was able to optimize inputs that get embedded close to the benign questions, but are detected as prompt injections or malicious attempts, even though they're not doing anything malicious. This way, attackers will try to grief your defenses to force you to disable them, which isn't great. So any mitigation that is put in place has to be seen as another thing that can be attacked and that will be attacked. And people will try to degrade the utility and quality of the models to force defenders to turn off mitigations. So now I think established the pretty miserable state of defenses and mitigations against prompt injections and adversarial misalignment. So I want to take a little step back and think about, follow a little train of thought that I recently had. And it started with this email that I received from the FBI. It says, "This is the FBI, and we are here in Africa as an FBI delegate that has been delegated to investigate these fraudsters who are in the business of swindling foreigners that came for transaction in Africa." So they're trying to convince me that they're actually the FBI that has caught the scammers in Africa and is now trying to send me money through them or something. You know, it's obviously the same scam email as earlier, but you can see the same level of indirection. It really sounds like a prompt injection. And that's when I started feeling like a language model myself. And I realized, well, you know, we are vulnerable to this. Humans are vulnerable to adversarial misalignment. Very vulnerable, in fact. The only robustness that we have is we had some selective pressure during evolution to not be susceptible to adversarial misalignment from agents with roughly similar intelligence that live in our environment. Because if anybody that you meet on the street or in the forest can tell you to, you know, slave away for them instead of your own goals, that's not good for your offspring, it's not good for your genetic prevalence, and that's not a preferred trait. So some robustness is good in multi-agent systems. But if we still are vulnerable sometimes, and there's no fundamental defense here, the question sort of arises, why doesn't society collapse off of that? And I think the main difference is that humans are just much better black boxes. It's not that they're much more intelligent or that they figured out some kind of mechanism that's, you know, significantly more robust than anything the AIs are doing. I think the sort of intuition here was for a long time that, especially with the adversarial visual examples, the noise that you see, these artifacts that are convincing the classifiers that a truck is a cat, those clearly don't appeal to us humans, and we're not vulnerable to them. Well, in fact, a few days ago, there was a paper showing that our judgments are also influenced and biased by these imperceptible attacks that we don't consciously perceive, and yet when only exposed for a short time, we do the same misclassifications as those classifiers. So I think a lot of features that we considered to be non-robust and only quirks of AI models that we have now are actually indeed predictive features that generalize to even our own behavior. Not all of them, but more than we had thought. And so if that's the case, what makes humans different? The black box, if you imagine the CIA had access to humans that were like language models. They're all the same, they're all very accessible and so on. I think they would have cracked the code and came up with prompt injections for humans as well. So to list them up, the differences I think that are relevant here in this context is one, the accessibility, right? If you have an accountant that's a human, they cannot be contacted as often as an accountant that's a language model that'll be ready 24/7 to respond to your questions. They can model your accountant at home, right? More importantly, it can be reset. So the language model can be reset into its same initial state every time, unlike the human brain, for which we can't do that, which massively helps with optimizing the first injection, like convincing the model, right? There's also a level of diversity that's lacking. So human brains aren't all the same. So if I find some kind of thing to convince, to misalign certain people, that's not going to generalize to the entire population. There are some cases where demagogues and dictators and so on have convinced a large part of the population to do something to change their alignment. But those are more exceptions. And generally the costs for the developing attacks are much larger because you need to account for the fact that human brains aren't all the same. If I develop one prompt injection against ChatGPT, it's going to work right away for all the hundreds of millions of instances that are deployed by users, right? And also, we can't observe the residual probabilities with humans, right? With language models, at least with the white box models that we have access to the weights for, we can observe the residual probabilities of it saying things that it didn't end up saying, like the bad thing that we wanted it to say, right? And so we can get a signal on making small changes and seeing how that feeds back. And that's very helpful in developing these attacks, right? Now, this is obviously just another stopgap. This is just resiliency and increasing the cost for attackers. But I think that's what we're going to deal with. Prompt injection will not be something that is easily solved. It's a fundamental issue of AI and general intelligence as well. And I think in the limit, it's going to come mostly down to compute. With the black box example here, for example, the issue is that if I'm optimizing an adversarial injection, the model is frozen. But I get to optimize thousands of times, iterate thousands of times, and spend a bunch of compute optimizing this one injection that we package and then send off. And I think that's a large part of why these are so successful and why it doesn't work quite the same with humans, while it still does. I mean, humans are still vulnerable, but society doesn't collapse. And at the end of the day, that's just all we want. We don't want things to never be compromised. We want to be able to organize a society and build applications and get utility from these models, right? So yeah, this is my summary in terms of new ideas. You diversify the models themselves. They should be online learning, so they shouldn't be in the same initial state. You shouldn't be able to reset them. Maybe that just involves keeping all the prompts and all the conversation history alive and not being able to reset it every time, right? I think that's something which Pi, for example, does in the user interface. Then you don't even need a new architecture or like a true online learner. You reduce the accessibility of your model and the ways that people can probe it. One example would be to infer residual probabilities from sampling probabilistic samplers multiple times. So if you have some kind of temperature-based sampler for your language model, and it's not entirely deterministic, but you don't immediately reveal the residual probability distribution, I can still sample it a lot of times and learn more about the entire distribution, right? And even if we do all those things, the trade-offs will still be unavoidable. Right now, the utility that we expect should go way down when it comes to integrations, and we're going to have to spend a lot of effort to like claw back every little bit of that utility. And yeah, we need to be very careful with the way we build models like right now. All right, that's it.